Okay, I was continuing on here with section 6.1, and I wanted to do a couple more restriction examples, but didn't think I would have enough time on the last video, so I started again. And what I was saying was we have how many 5-digit odd numbers can be formed larger than 50,000 but less than 80,000 without repeating the digits. So we have to look at the cases of all the odd digits. So we're going to have a few different cases here that we're going to look at for each of the odd digits. And I'm going to draw out, since there are 5 odd digits, 5 cases. Okay, with the 1, with the 3, with the 5, with the 7, and with the 9, what are the cases possible? So if this was a 1, we have 1 there. These will all be one choice here. Then we have to start thinking about the choice here, because there's a restriction on the first digit. It has to be larger than 50,000. Okay, so that could be a 5, could be a 6, could be a 7, but it could not be an 8, because as soon as you get to an 8, it has to be less than 80,000. So it could be a 5, 6, or 7. 5, 6, or 7. So how many decisions is that? That's 3. So we used up the 1, we used up the 5, 6, or 7. So one of those. So we used up 2 digits out of a possible 10 digits. So how many digits are left? 8, 7, and then 6. You just count down because you use up a digit. Now we'll do the restriction with the 3. It's a similar type of thing. Again, the restriction on here, we can have a 5, we can have a 6, or we can have a 7. Okay, the 3 is used up, and one of those digits, so 8, 7, or 6. Okay, we have to be careful when we get to the 5 here, because the 5 is used here. We can use the 6 or the 7, because we won't have any of these digits for the 50,000. So we can use the 6 or the 7. So we used up 2 digits already. One of the 6 or 7s, and also a 5. So we still have 8 digits there, 7 digits there, and 6 digits here. A similar thing happens here with the 7. We can use the 5 or the 6, but not the 7. And again, we have the same sort of idea. Now when we get to the 9, okay, and 9's at the bottom, so we can only use a 5, 6, or a 7. Okay? And then we used up the 5, 6, or 7, so we still have a similar statement here where we have 2 digits being used up. So now we take our calculators, figure these out. 3 times 8 times 7 times 6. So this is 1,008. So there's a similar one here. 1,008. Okay, this one's a little bit different, but this one here is also 1,008. Okay, so we have to do those 2 middle ones. 2 times 8 times 7 times 6. And that gives us, oops, push the wrong button. 2 times 8 times 7 times 6. 672 twice. So then we just add these up to get our total value here. And I get 4,368 ways. So you have to be careful when you have restrictive cases. You have to think about your decisions carefully that you're using. Okay, we still have enough time to do our second example with restrictions here. Okay, it says how many 4-digit numbers can be multiples of 5 with no similar numbers? How many 4-digit numbers can be multiples of 5? I just did that one on the other page. I must have repeated that one twice. So we'll stop there. And in our next section, we'll be looking at permutations.